Hey everyone, welcome to the 18th episode of the Coffee with Cosmos DB series. If you have missed to join our last episode, you can watch the recording, which is available in the playlist. And before that, I would like to announce a couple of things. There is a Microsoft Ignite, which is coming up in 2 weeks' time. So you can start registering to participate by using this URL. And yeah, if you would like to talk about a particular feature or a topic, please ask in the chat. And also we have opened up a community tab, so you can paste it there as well. If you're joining this series for the first time, this series is all about spreading the knowledge on Cosmos DB by experts to the community. And also, if you're a community member who have done projects on Cosmos DB, please feel free to sign up. Make sure to subscribe the channel and share with the community members who are looking to learn more about Azure Cosmos DB. With that, let me introduce our guest for today. He's not new. He has been in this series previously as well. Welcome, Abhinav.
Hey, hi Sajid. Thanks so much for having me here again.
How are
I
you
was
doing?
waiting. I I'm doing good. I was waiting for your invite again. I was like, when will
Sure, sure. You
I
are
get to
always
be
welcome. Yeah.
there?
I think last
Yeah,
time you spoke about throughput calculator. So this time,
correct.
again, it's going to be developers topic. You will be talking about Python SDK and have a demo as well, I guess.
Yeah,
Yeah. So probably you can introduce again for the new audience who are watching this for the first time.
yes. I think last time when we did this, it was second or third session, and we
Yeah,
are already on the 18th one. So
that's right.
yeah, we have come a long way. Hi everyone. I am Abhinav Tripathi. I am a program manager on Azure Cosmos DB team. It's been almost more than 2 years. Yeah, so I'm looking after the Python SDK, the whole Python ecosystem for Azure Cosmos DB, and apart from that, I'm looking after a couple of other features as well. Last time I talked about throughput calculation on Cosmos DB, understanding of RUs and all that. So this time, Saji and I, we were discussing about Python ecosystem. So Saji has keen interest in JavaScript ecosystem, and I look after the Python SDK. So recently there has been a lot of new developments, Saji, as we know, uh, with the OpenAI coming up with a lot of AI use cases, and
Yep.
that's when the Python SDK became a hot entity within Azure Cosmos DB as well. So a lot of data science folks, the AI ML folks, they use Python in their projects, and then the natural choice becomes a database which supports, direct interfacing with Python.
Yep.
So that's how we are here. We'll be talking about our Python SDK, what are the new and the hot additions to our Python SDK, how it could help the developers in achieving their day-to-day tasks, whatever they will expect from a good database ecosystem. So, Saji, before that, I would like to ask, is there, a particular question in your mind, or I could start with, introducing the features that we have, the capabilities that we have developed in near future, in recent future. Mm,
No, I don't have any questions, but for the audience, probably I would ask a question like how easy it is to get started with Python SDK with Azure Cosmos DB. I know that we have this getting started page, but do you have any other resources that you recommend for someone who is
Yeah,
very new? Yeah.
yeah. So if we look at Python ecosystem, we have primarily two use cases. One is web development, where people are setting up their web servers and catering to applications like ordering systems and all that. So there they have to develop their own APIs to talk to a two-tiered architecture where they have a middle layer of APIs that talks to databases, or they use it in their machine learning projects like storing embeddings and all those things, or storing the data models, all those things. So those are primarily two use cases. So coming back to your question, I did write a blog around how to get started with Cosmos DB, and if you look at the getting started, we usually, start with some practical use cases. So the block covers uh, writing a data layer with fast API and Cosmos DB. We will come to it later, but
Okay.
maybe before that, I would like to talk about a couple of features that we introduced and that helps the developers. I mean,
Yeah, go
not
ahead. Yeah,
starting
yeah,
ones, but the developers who are using, introducing some serious uh, workloads on Cosmos DB and they want to use it with Python SDK.
yeah,
So,
go ahead.
Saji, I have put up just one slide to, guide us through the session where uh, I will be covering about async IO, continuation token support, hierarchical partition key, batch API support, and transactional batches. So I have put the links as well. Maybe you can share with our audiences
Yep.
here, the viewers, for later references. So without further delay, I will, start with async IO. So this was a long-standing ask, and it has been there in Python SDK for more than a year now. But I wanted to emphasize on this piece as well. So you are coming from JavaScript world. I think you have must have been using promises for long, Saji, right?
Yep.
So
Yep. Yep.
we have sync and async programming. So in a database there are many, long running tasks. Let's say we are running a query and then we want to perform another task as well. Now the query is taking long time to, maybe the call goes to the database and then processing happens and then the result comes back. Although Cosmos DB has latency guarantees on point reads and all those things, the SLA guarantees, but the queries, they will take time depending on the complexity and everything. So there might be some long running operations which take time, and then you cannot keep your, the application blocked. Or if you want to run concurrent operations, how do you do it? So for a very long time the Python SDK did not support async operations, but during the last 1 year we worked on a lot of user feedback, and we this was the first thing that we built, and now we do support async operations on Python SDK. During as I will walk you through my blog, you'll also get to see how we implement. It's just like async methods and awaiting calls on those. So that is one thing. So it is not new, but it is very hot. It is, one of the most demanded feature that we implemented. Then we have continuation token support for cross partition queries. uh, so when we have, long list of results
I
and
have
we
a
have.
question on the previous topic on the async IO.
Yeah, yes, Ajay.
You talked about the benefits, including running parallel operations, but does it have any implications on the performance? I mean,
Async in general,
yeah.
it improves the performance. You can,
Okay.
run parallel uh, task, and then you can get the callbacks, you can get the results. You are not blocked on the
Okay.
processing part. So in general it improves uh, your
So your
experience.
recommendation here is to, like, whoever using Python SDK, go with async IO operations. Is it?
Yes, yes.
Okay.
Yeah,
Got it.
there might be some situations where you want sync operation one executing after the other, but
Mhm.
in general it will be beneficial for the larger crowd.
Okay. Got it.
Yeah. Then yeah, continuation token. So let's take an example of Facebook, right? So we have hundreds of posts coming on Facebook. If we scroll through the wall, okay, I should be bringing up Instagram because Facebook is, quite old now. So if you are scrolling through reels, and there is a long list of results that you have to display. How do you do it? Either you fetch, let's say, thousands of results and then you maintain how many results you have displayed, or you have a way to, execute the query, get the results, and then query for more items as user goes through the result set. Because if I have 1,000 results, the user might want to look at, maybe let's 100 only, and then they might find something and they might not need to load the other 900. So continuation token is in general a mechanism where when you are executing a query, you are getting the result. Along with the result, you get the continuation token, and using that continuation token, you can ask for more items. So for a very long time, Cosmos DB did not support continuation token on cross partition queries. So by cross partition query, I mean to say that in Cosmos DB, depending on your partition key choice, your data is distributed among different logical partitions, and each logical partition will reside inside a physical partition. So if you have a query which is going across multiple partition keys, so the result might be fetched from multiple physical partitions. And in that case, if there is a query fan out, we did not support continuation token for such queries. But now we have built that support. It was also a long-standing ask. It was an ask from our AI community, AI users community. So that is a critical addition to Cosmos DB Python SDK. Now we do support continuation token support for cross partition queries. Then the next in line is hierarchical partition key, which is a very recent addition. We were again lagging on that part. So as you are aware, we have a 20 GB limit on the logical partition size, Saji. So if your use case requires to choose a partition key where you might exceed the logical partition uh, choice. Let's say there is a company and there are several organizations inside that company, several teams. So you could choose the company as the partition key choice. But since you have the data related to several teams, it is likely that your data might go beyond 20 GB very fast. So company the choice of partition key, you can choose the company name as the partition key, but it might scale up to 20 GB very fast. The next choice is you can have a combination of company name and the organization as the the partition key. But in that case, if you want to query by the team name, the organization name, then you'll not be able to perform the point reads. You'll always have to supply the company name and the team name, and then you'll be able to perform the point reads. So the other thing is, let's say, if you could have several level of hierarchy inside your partition key. Let's say you could make company name slash team name as your partition key. So what happens, every combination of company name and team name, it will have 20 GB quota. So the logical partition, it is not that likely to exceed the 20 GB limit. Also, you could query specifying the company name or the team name or the combination of both. So it uh, improves your experience on that querying part. So this is another addition to Python SDK. We are working on some improvements. There are some limitations as well. So the link that I have shared here is from private preview. So it was in general in private preview. Now we have implemented it for Python SDK as well. It was available in other SDKs.
Got it.
Then
Which means like users can create containers with hierarchical partition
yeah,
and
yeah,
then
up
they
to
can
three
do
levels
all
of
the. Okay,
yeah,
got it. Okay.
yeah, up to three levels of hierarchy they can define. Yeah.
Yep. Go ahead.
Yeah, then Saji, another very useful feature which was missing from Python SDK is patch API support. So we do have normal inserts where you can simply insert a record, a document in your Cosmos DB collection, but then we have upserts. So if you knew a particular item ID partition key, you could specify, okay, you want to, uh, update that item, that document, or if it does not exist, then you could insert it. But the problem with upsert is, like, let's say I'm storing image data, and in image, every pixel is a RGB value. All right. So let's say both of us are working on something where we are storing, let's say you are playing around with R values and I am playing around with G values. So if I currently have a data as 000 for RGB, and you also have the same data. Now let's say from your application you edit r value to 1, and now your whole record becomes 100, and you upsert it. The information gets changed, but I had 000 and I change the g value to 1, so it will become 010. Now when I upsert it, your record, whatever you wrote, it will get overridden, and the final value will become 010. So you wrote 100, I wrote 010. Since I wrote at the last, the
Mm.
item will become 010. So to overcome that, so that people can, work in isolation, and you can update just single field, patch API becomes, very important, and it comes in handy. So if you use patch API and you send 100, and then I uh, you do not have to send 100. You just specify that you want to change the r value, and you send the update for that, and it will be changed to 1. And then when I have to modify the g value, I send an update for that, and patch will change that, and the final value will be 110. It will have your change, it will have my change, and then the record will be merged. So patch API also comes in handy, and then Python did not have that. A lot of image processing use cases are there with Python, a lot of other use cases where this comes in handy. So now we do have patch API support as well. It's not very recent, but still, like during the last 6 months we have rolled out this support. The
Okay.
other, yeah, do we have any questions, Saji?
There is one question, but that is
Hmm.
not related to any of the topic.
Okay.
When is the direct mode support on Python SDK?
So Python is a gateway SDK. So we are, discussing those things, but nothing official as such on those. So I cannot commit to any timelines or, uh, roadmaps on that.
Okay, got it. Yep.
Yeah,
Yeah, that was
yeah,
the only question.
yeah. So there are definitely discussions every now and then around those things, but we do not have any, commitments so far. And then I wanted to talk about transactional batches. This is something we do not have so far, but this is a capability that we are building. So it will very soon be out there. So transactional batches, there are two two use cases where you want to update the documents in bulk. So there is a bulk scenario where you have a lot of documents that you want to update, and you want to utilize the throughput and all the resources in the most optimum way. So those are bulk executors. But then transactional batches, how do they differ from bulk implementation? Is that let's say you have a banking transaction where a set of operations have to happen when somebody withdraws money. So first, you have to calculate what will be the balance after the withdrawal, and then you have to update, and then the operation will be closed. So such operations where you have to make sure that there is atomicity, and then either everything succeeds or everything fails. So in such cases, transactional batches come in handy. So you specify a set of uh, operations that can be executed within one transaction, and if any of the operation fails with that transaction, then the whole transaction is rolled back. Nothing gets effect. So that's where transactional batches come into picture, and we are building support for that as well. It will be out there very soon.
Got
So
it. Okay.
those were the few very important features that I wanted to discuss, Saji. Yeah.
Yeah, thanks for
And
sharing. I think these are very useful. I personally love the async IO and also I mean, all the features, but for developers, I feel, um, the async IO and also the patch transactional batches would be very useful.
yeah.
Yeah, thanks. Do you have anything other than these to
Yeah,
share?
yeah. So I wanted to quickly go through. blog post that I wrote and share some uh, my dev environment, show some code to show
Okay,
how easy it is to get started with the Cosmos DB with Python SDK. It is really easy. So
got it. Yeah, that would
yeah,
be very good.
let me start by sharing my screen. I'll be sharing tabs one by one. There might be some delay, Saji.
Yeah, no
So
worries.
yeah, so this is our PyPy page where we release our Cosmos DB, Azure Cosmos DB, Python SDK. So here we do, keep a change log, and you can get to know what are the new features that we are rolling out. So this is something which comes in very handy if you are trying to get started with Azure Cosmos DB Python. So this is the place to get started with. And then let me share the blog post. Okay, yeah. So yeah, this is a very detailed blog post, not to scare anyone, but to for helping those who are just getting started. If you do not have any experience with Cosmos DB, you can follow this blog. I will walk you through the steps, and you'll realize it's very easy. So I'll tell you how the structure is. So let's say we have to build a to-do application where the user from the to-do application, they can create an item or delete an item or update an item. So whenever you are creating an item, uh, we have to insert an item in the Cosmos DB. If you are deleting, we have to delete it from there. If you are updating, we have to update there. So we could directly talk to Cosmos DB, or there is a uh, two-tier architecture where I think it's called two-tier only. So correct me if I'm wrong. So there is a middle layer in between where you introduce your own API layer. The benefit of API layer, as I see it, is if you have to modify something before talking to database, so you can do it at that level. So API layer, what it does, you write some certain functions, and you expose those functions at your application side. You do not have to expose any database uh, logic there. And then in your API routing, you could write that logic, and then it fetches the results from the database, and then the application gets those results delivered. Uh, so this is a simple application. I have all these steps laid out there. You first create a Cosmos DB account, and what are the important, terminology, the subscription that you'll need, resource group, account name, location, everything is, laid down here. If you follow this, it is a step-by-step guide. You can choose whatever capacity mode for, your hobby projects. We do recommend that you start with serverless. It's easy to try out a lot of things with serverless, and you pay only for the the as many calls as you make. You do not have to commit to a particular provision throughput. So once you deploy your Cosmos DB account, you get to see your primary key and the secondary key and the URI. So these are required for making connection to your Cosmos DB. I'll walk you through the code as well, but these are the important points. So URI, it identifies where your request will go to which account, and then primary key is basically the the connection mechanism. With using the primary key, we know that okay, this is coming from a trusted application. So using the combination of URI and primary key, we will connect to our Cosmos DB account, and then we have certain setups to do. You can totally avoid it if you are, uh, well aware of how to set up a server. So this is for dev environment. you need to set up a server if you want to test out, fast API and how it will all work. So we have a couple of tools and libraries that you need to install. So you could install fast API, and it helps in writing that API routing logic. Then UVcorn server, which will run a uh, ASGI web server implementation for Python. It will run a server on your local machine. Then .env, this library we use to uh, save our primary key and URI in a .env file, and then to read it, it should not be used directly in the code. Then AIO STTP helps us in async implementation of HTTP client server calls. So that, and lastly, we'll install the Azure Cosmos DB library for Python, as we saw in the beginning. Once all this is done, we have the code hosted in our GitHub repo that can be cloned. The link is here in this blog itself. And now I will switch to our dev environment. You don't have to, change a lot there. Uh, Let me switch to the dev environment. Yeah. So if you look at it, uh, we have this structure. There is a main file, there is models, there are routes, and then there is a .env file. .env file is used to store, the URI and the key. So key, obviously it's longer than this one, so we should not share the key with anyone. So in the .env file, you simply specify the URI and key. When you have the code from the repo cloned, you use your own URI and the key here in a when you clone it, it will be blank. It will say to supply your own keys. Then we have main.py, which has all the logic. So we load the credentials from the env file first, and then we specify the database name and the container name. If these exist, we'll not create it. If these do not exist, then we'll create these databases. And then this is a standard fast API way to get started with API routing. So this is the standard method when you write your API layer. This is the async method that I was talking about, Saji. So when you are defining the async methods, you start it with the async um, keyword. And then if you look at it inside the async, you have to use await. So get or create DB. So when you are getting the database, you are actually making a call to Cosmos DB and trying to see whether this database exists or not. If it does not exist, then create the database. It will take some time. Okay, so we make this call inside async anyways. We have to make the network calls with await keyword, so the results will be await should be awaited. And if you look inside the get or create DB method, so the first step in Cosmos DB is get the URI and the primary key. If you want, you can get authenticated with RBAC as well. So I'm not covering that in this session, but Python supports that as well. So first step, when you get connected to Cosmos DB, you then check for the database whether that exists or not. If you are creating a new application, you check that and create the database. If the database is created, then you might need to create the collection if it does not exist already. So you'll then get the collection. If it does not exist, then you'll create the collection. So that's what this method does. And then once you have the container and the database as well, then we start looking for data. We can create new data in that, or we can query that, or we can delete that. So this is simpler. In the database variable, I'll store using Cosmos client dot get database client. I specify the database name. If it exists, I'll get a database. And if it does not exist, I'll get this resource not found error. And in there, I could create the database. Similarly, for container, I could first check whether I can try to get the container. If it does not exist, then I can create the container. So this is as simple as that. You first just load the environments, environment variable, and then you simply try to check whether the database exists or not. If it does not exist, then create it. Similar thing with the container. Now going to the models layer, what happens? So our to-do item in this case, it might have several fields. So if we want to ensure and implement that hygiene, that okay, each to-do item that is returned from our API calls, it should have a ID, name, description, and a boolean whether it was completed or not. We could define it here, and we could specify whether these fields are optional or not. These are basically implemented by Pydantic models. So this is how we define the model. In our case, it will be ID, name, description, and is complete field. Then going to the routes.py, this is where we define our, API routes. So simply we start, this is the standard way, we instantiate a API router inside the router, and then we specify whether a particular call will be post call or a get call. So here we are specifying, okay, this is a post call. This is, if we say we call insert and then we provide a to do item with a post call, then it will insert, it will create a new to do item. Similarly, if we make a list all API route, so whenever our application goes to the list all path uh, and it is a get request, then we'll get all those items. So this is how it is done. We'll get all the to do items, those are existing in our collections. Then again, for updates, we make a put call and we specify a particular item. So we read it from the database and then we make the changes to the particular fields that we want to update, and then we make a put call and send it to the database again. So this is a simple replace to do method where you specify the to do item and it will read the existing item. If you see it here, existing item await request app to do item container, read the item first. This will give me the existing item. Then I can tweak particular fields that I want to change, and then I can send the updated item back and it will write. And similar for delete. So it is very simple. So if you want to build a data layer, you just need, a routes.py, you use fast API general coding rules, and it is very simple. You write your own methods or your own API calls, and then specify whether it will be a post, get, or put call, and you specify your API call contracts, and then as you implement it, you can test it when you run it on Ubicon server. You can actually test it out. I do not have it set up here. Otherwise, I could just uh, run it through you. Yeah. So this is all I wanted to share, Saji. I'll
Yeah,
stop
thanks,
sharing.
Abhinav. That was very useful. For those who haven't explored Python SDK, you can start building applications with the blog post that Abhinav shared and also with the sample code. Yeah, there's a
Yeah.
question maybe I will
Yeah.
ask. Can you elaborate more about Fast API? Is it a framework? Whether this particular quick start that you showed, whether it can be used directly with a Flask or Django app? Like, I think those are frameworks on Python.
Yeah, Fast API is, in general used for API routing. So you can use Flask and Django. They might have their own set of other libraries as well, where you can define those routes
Okay.
yourself.
Yeah.
Yeah, Fast API basically is, it's a very popular framework library for API definitions and routing. So this is very popular. So that's why I wanted to cover Fast API. And in
Yep.
servers
I
also, I could use Flask server or Django, but I chose to use Ubicon here.
got it. Okay.
Yeah.
Yeah. Thanks, Abhinav. This was very useful session and also especially for developers who wanted to use Python SDK. Yeah, thanks for your time. I don't see any other questions on the chat, but if you have any questions, you can post it as a comment on the video itself. We can take them offline. Yeah, thanks everyone for joining. We will meet again in a couple of weeks, and thanks Abhinav once again.
Thanks, Ajit. Thanks, everyone.
Bye.